Welcome back. Welcome to Chapter 7. We are going to start doing Laplace transforms. We did a little Laplace transform in our reading. We're going to do a second example here in a video. In this particular example, we're trying to derive lines number 1 and 2 in the table. And these are two lines dealing with the Laplace transform of a derivative of a function. How do we find the Laplace transform of a derivative? The Laplace transform of whatever's in here is defined in this way, right? Whatever's in here goes here, and it's an integral. So the Laplace transform is defined as an integral. This particular integral, we're going to need integration by parts for this. So we'll have u equals e to the minus st, which means du is negative s e to the minus st. And that leaves us with a dv in there, which is y prime of t. And the antiderivative of that, v, is just y of t. So we have all of our pieces for integration by parts. The actual integral for integration by parts, right, we're going to have the Laplace transform of y prime of t is u times v. So that is y of t e to the minus st from 0 to infinity minus the integral of v du. So y of t, 0 to infinity on the integral, e to the minus st dt, and I'm going to take the minus s out of the integral. The integral is with respect to t. S is a constant as far as the integral is concerned, and so I can bring it outside of the integral. And this is what I have. Now, looking at this right here, plug in the endpoints of integration, and e to the minus infinity is 0. So this looks like 0 minus e to the 0 is 1. So 0 minus y of t. And then notice right in here, this part of the integral is the definition of the Laplace transform. So this is the Laplace transform of y of t. So if we put all of this together now, we have the Laplace transform of y prime of t is s times the Laplace transform of y of t minus y of 0. Or I should have put the 0 in here. I was evaluating it at the endpoint of integration. So that should have been a 0, not a t. And that is line 1 in the table. The Laplace transform of a derivative is s times the Laplace transform of the function itself minus the function evaluated at 0. Let me show you now how we can use that to get the Laplace transform of y double prime without doing more integration. So again, here's our result that we just showed using integration by parts. I would like to use this to figure out what is the Laplace transform of y double prime. So y double prime is just the derivative of y prime. So I'm going to use this formula that we just derived, but I'm going to use it with y prime and y double prime instead of y and y prime. So this will look like s times the Laplace transform of y prime of t minus y prime of 0. So I'm just directly applying the formula we just derived to y double prime. Again, y double prime is the derivative of y prime. So where I have y's on the right-hand side, now I have y primes. And now the Laplace transform of y prime, we know, is s times the Laplace transform of y itself minus y of 0. And then I have this minus y prime of 0. So I'm just substituting in right here. I'm substituting this line in for the Laplace transform of y prime. What that gets is the Laplace transform of y double prime of t is s squared times the Laplace transform of y of t minus s times y evaluated at 0 minus y prime evaluated at 0. That is item number 2 on the table of our Laplace transforms. So we get the first one through integration by parts, and then we can get the Laplace transform of y double prime just by substituting some things in. We could get y triple prime, the 4th, 5th, 6th derivative in the same way, just substituting in at this point. And there's definitely a pattern that's starting to emerge here, and you can see what it would look like. But all we will need for class is the Laplace transform of y prime and y double prime, and this is where they come from.